happens.
And you can go to
What it does. Yes, I am.
I'm working with Kai.
I hope I have it. If I don't.
I would-
You didn't have any
In the trials.
All right, so last week we started talking about Unit 1 and Unit 2 review for the test. Remember, there's going to be a 2-part test Friday and Monday. So any questions on Units 1 and 2?
How many units are there?
5.
Wait, I have a question for the test. Is
Sure.
it just gonna be like, so you know how for the homework, we did like one question for each like category?
Yeah.
Like, is that how the test is gonna be too?
Yeah, it'll be less than that because I have to fit it into 2 days. So it won't be like 5 whole units. It'll be like just questions here
So
and
it's
there.
kind of like about 30 questions in total, sort of, because like on the test.
Probably
it's
less.
kind of
It's probably like 10 on each day.
Oh, okay.
Oh.
Can we get like full test time?
I don't know.
Yeah,
Maybe we
Okay.
can't.
correct. No test corrections. Okay.
Yes, you better do it right.
Any other questions? Yeah.
Can we go over, so when you're, transforming rectangular to polar form?
Yeah.
Sometimes you have to, like, get a different angle. And
Yeah.
Can we go over how to do that?
Sure. Yeah. So like, for example, to go from rectangular to polar form. For example, what if you have the point -2, -3, and you want to change that into polar form? So we have 2 formulas, right? The 2 formulas are r equals the square root of x squared plus y squared. So this would just be the square root of 4 plus 9, right? Which is square root of 32. And then we have theta is the inverse tangent of y over x. This would be the angle whose tangent is 3/2. So if you do that on your calculator, my calculator is actually in radians right now, so let me change it to degrees. If I take the angle whose tangent is 3/2, I get 56 degrees roughly for the nearest degree, 56 degrees. So this is a perfect example where if you actually did this and went radical 13 and then 56 degrees, it would end up like up here somewhere, right? But we know that this point is actually over here at -2, -3. So this is the situation that might occur sometimes. You might end up with a point that's like 180 degrees away from where it should be. So there's 2 ways to adjust your answer to make it correct. One way to adjust it is you could just make r negative. Like if I took the point to be negative radical 13, 56 degrees, that would get me to the right place, right? Because think about it. If I went negative radical 13 and then went 56 degrees counterclockwise, that would get me exactly where I want to be, right? Another way to fix it is to, instead of making r negative, change theta somehow. So the way that you would change theta is you just use the reference angle. Like if these are 180 degrees apart, that means if this is 56, then this is also 56, right? So to figure out the appropriate angle, if you keep r positive, you would just go 180 plus 56. So this would be 236 degrees. So this is just 180 plus 56. I'm just using reference angles to get the correct angle. Does that make sense?
Will delta nav make one of, like, if you did the negative degrees, like, is it gonna say that it's wrong?
It'll give you.
Did the negative degrees?
Like, like,
Negative r?
yeah,
Yeah, I don't know. Does anybody know?
It'll say like, make r positive.
Yeah, so it'll tell you. So if it said, for example, make r and theta both positive, this would have to be your answer.
I just can't remember if it told.
Yeah, I can't remember either. But any other questions? Does that help?
Yes.
Okay. Okay. Any other questions on units 1 and 2? Okay, so unit 3, this is unit 3 review. This was all about graphing functions without a calculator and doing transformations on them. Okay, so remember we had several basic functions of graphs that we needed to know. Graphs of basic functions. So the basic functions that you should definitely know how to graph are y equals x, which is just a line, right? Y equals absolute value of x, which is a V-shaped graph. It just takes all the y values and makes them positive. This. X squared, which is a parabola. X cubed, which is like this shape graph. Radical x, which is half of a parabola opening to the right. Cube root of x, which kind of looks like radical x, but it just like continues over into the third quadrant, like that. One over x, which is like the inverse variation hyperbola in the first and third quadrant as asymptotes. 1 over x squared, which is just in quadrants 1 and 2 instead of quadrants 1 and 3. Exponential functions, a to the x, which is just also has an asymptote, horizontal asymptote that way, passes through the point 0, 1. Log base a of x, which is the reciprocal of that, or not the reciprocal, inverse, sorry, inverse of that, passes through 1, 0. Sine x. So it is a periodic wave type function like that. Thanks. Cosine x. So that one, it's also a wave, but it just starts at a different place. That. And then the final one was like the weird step function thing. That. So it is steps. So it looks like this. Okay, so those were the basic functions, 2 of them. So you need to know what all those look like. And then the second part of this was just transformations of these functions. Okay, so transformations. And we had basically like 3 types of transformations. We have translations, which were if you add something to a function, like f of x plus b, or if you add something to just x or subtract something from x, x minus a. Okay, this is a shift up or down. and this is a shift left or right. So remember, with the left and right translation, it's opposite of what you would expect. So like, for example, if you had something like, well, for the vertical translation, it's what you would expect. So if it was like x cubed plus 3, it just looks like x cubed put up 3. So it's just going to look like that. But if it was something like x plus 3 squared, this is going to be 3 to the left, opposite of what you kind of expect it to be. So this is going to be 3 to the left, and then it's going to be a parabola x squared.
So like, would that happen because you're like, whatever function you're like, either if you're like adding or subtracting, like you're still technically doing the other one. Like it just looks different, like it looks wrong because of the way that it's formatted. Like,
Yeah, this is x minus whatever the x value is. So this is
Right.
really x minus negative 3.
Yeah.
Which is why it's moving 3 to the left.
it makes sense.
Another way you can think about it is like, if you want to compare it to x squared, like what would you have to substitute in here to get the same y value as you would at 0? You'd have to substitute negative 3 in, not
Yeah.
positive 3. You know what I mean? So,
Right.
so at negative 3, this graph should look like it does at 0 on the normal x squared graph.
So you really are subtracting from the value, it just looks like you're doing that.
Yeah, yeah. Okay, so those are translations. The next two we did were reflections. So this is if you take the whole function and make it negative, or just make x negative. Making the whole function negative reflects it over the x-axis. Making x negative reflects it over the y-axis. So this is over x-axis, and this is over the y-axis. So something like y equals negative e to the x. This would look like a normal e to the x function, but reflected over the x-axis. Looks like that. If it was something like y equals the square root of negative x, this is making just x negative. This is going to reflect radical x over the y-axis. Now, okay? Are we okay with those? And then the last two were dilations. So this is where you multiply by something. So you can either multiply the whole function by something, or you can multiply just x by something. Multiplying the whole function by something stretches or shrinks it vertically, vertical dilation. And this is a horizontal dilation, stretches or shrinks it long ways, or horizontally. And remember, with the horizontal dilations, again, it's opposite. So if it's a small number, it actually stretches it. And if it's a big number, it shrinks it down. Vertical, it's just how you would expect. Big number stretches it, small number shrinks it. So something like y equals like the cube root of x divided by 2. This is like multiplying by 1/2, so it shrinks it down vertically. So if the cube root of x looks like this, then 1/2 of the cube root of x looks like half as tall. Same general shape, just squished down. And remember, the key to these in Delta Math is pick a point that's nice and convenient, like a number where the cube root is known, like 8 or 27 or something like that. You pick that point and you drag it down. don't pick like 3 and try and drag it down. It's gonna give you the wrong answer. Even though you got the right idea, you gotta sort of work with delta math and pick a point that's gonna be like a nice answer, or else it's not gonna register if you know what you're doing. Does that make sense? And then the only other part to this unit was even and odd functions. So remember, this is even odd functions. So an even function, remember, is symmetrical over the y-axis. And there was a little algebraic test for evenness, and it is f of x equals f of negative x. So if that's true for all values of x, then the function's even. And then for odd, that means symmetrical to the origin. So that means it looks the same upside down. If you rotate it 180 degrees, it looks the same. That's what symmetrical to the origin means. Think of like x cubed, the graph of x cubed. If you flip it upside down, it looks the same if you rotate it 180 degrees. So this test is f of negative x equals negative f of x. So if that's true, function is odd. Okay? The difficulty with this chapter just was the delta math thing where you have to like graph transformations. So just try and do it one transformation at a time. Like if there's more than one thing happening, don't try and do everything at once. It's way confusing that way. So if I have something like, for example, y equals 2x squared minus 1 or something like that, don't try and do everything at once. Like do one thing at a time. Start with x squared, right? And then you just do one transformation at a time. So 2x squared would be steeper, right? It's like a taller, stretched out version of a parabola. So you just pick a point like 1 or 1, 1 or something and just drag it up to 1, 2, right? That's how you do that on delta math. And then 2x squared minus 1, that means you take this graph and you shift it down 1 unit. So it's going to be down 1 unit, but still like a stretched out version of a parabola. Okay, if you try and do 2 things at once, it will be probably wrong in delta math because it's confusing to do that. Any questions about that? All right, so that's it. The homework is on delta math, and it's just called unit 4 or 3 review.
Can you go up?
Yeah, sure. Tell me when.
Right there.
Right there?
Wait. No, wait.
Not there?
It's a reflection. I wasn't here.
And
Right there?
Perfect, thank you.
Yeah.
You think you could go to the top?
I bet I can.
It's your numbers. So like if you have 50, 60, or 70, you're pretty much set. Thank you.
How's that?
But negotiation, 40 is kind of an ambiguous middle ground, but if 50, 60